Hello and welcome to my video, lesson 2.1 on radical functions. This will be hopefully a relatively quick summary video of what we learned in class, but we'll see how the timestamp below shows how long this is going to be. Radicals will be just square roots here. We're not looking at cube roots or fourth roots or something like that at this point. So we're just looking at square roots. Okay, so to begin with, first of all, we have a lot of practice with parent functions and therefore with transformations. So we have a lot of practice there, and we're going to use those skills when we're looking at a lot of different topics, including radical functions and including, well, a little bit into rational functions, but as well as into the next unit in trig functions. So anyways, we have the parent function, which is y equals square root of x. So if we just make a table of values here, table of values looking like this, we would have x equals 0, y equals 0, x equals 1, y equals 1. Then the next big jump is y equals, x equals 4, y equals 2, right? And then x equals 9, y equals 3, x equals 16, y equals 4. And that's because we're square rooting to go backwards, right? To go from the x to the y value. We're square rooting. So with that in mind, it's kind of a weird step up per x value. It doesn't step up by 1 every time. So let's plot this on the graph and see what it looks like. So first of all, we have 0, 0. That one's easy. 1, 1, and then we have 4, 2, and then we have 9, 3, and then we have something further. So it'll look like this. Okay, so this is the parent function. This is y equals square root of x. So if we just look at that function and try to talk about the domain and range, well, we can say that the domain is that x has to be greater than 0. So greater than or equal to 0. For y, it has to be greater than or equal to 0 as well. Okay, that's just for the parent function. Okay, now remembering transformations, we can actually use the exact same transformations, k and h as translations, a and b as stretches, and we can do the same thing to this sort of function, to a radical function. So h and k translate, a and b stretch and reflect. So let's try this right now. So again, the original equation goes from 0, 1, 4, 2, 9, 3. Okay, so this is the original equation, but now let's go ahead and try this out. So the vertical, so first of all, let's move the 0 point. Okay, this is the easy one to move. It's going down by 4 and to the left by 2. So our original point here moves to that spot. Okay, that's based off of these two. And we'll move other points in a moment, okay? But then our next, well, actually, let's do the rest of them. It's going to go like that, it's going to go like that, and it's going to go like this. So this is what it looks like so far, but we've only included these two. We haven't done this one yet. So let's do that stretch, which is a vertical stretch about the x-axis. Okay, so it's being stretched so that every point that is, a certain distance is going to be stretched a further distance. Okay, and I mean, let's just try it in our calculator just so you can see the difference, and then we'll draw it on the graph here. So the original one is y equals square root of x. The new one is 2 square root of x plus 2 minus 4. Oh, whoops. There you go, minus 4. Okay, and so if we graph it, we'll see here, you'll notice that it looks like it has stretched, but if you look at this origin point, it actually hasn't moved. So that's actually not going to move at all. but every other point will have moved. So the stretch actually kind of happens first, I guess. So it doubles, so it's going to go like this, and then it's going to go like this. And then it's going to go like this. So it looks a little bit weird, but I think that kind of shows it pretty well. Yeah. So again, if you kind of just do it one step at a time, you're probably better off. The easiest thing to do is always to move that origin point first. Okay, so move that origin. Okay, so for step 1. Okay, then step 2, stretch. And then after that, translate the rest. Okay, that's how I think about it. But let's go ahead and try another one here. Well, it's going to be a slightly different situation going on in this one. So let's take a look here. Graphing y equals square root of f of x from y equals f of x. So what we're doing is we're taking a function and square rooting it, taking the root of that function. So if f of x is a negative value, then it does not exist. So you can imagine that if we have a negative value inside the square root, it's an imaginary number, and so it does not exist. Okay? When it equals 0 or 1, there are invariant points. Okay? So they're going to be invariant points. So wherever f of x equals 0, they're going to be invariant points. Or f of x equals 1, they're going to be invariant points. Okay? So you can imagine that square root of 0 still equals 0. Square root of 1 still equals 1. That's what that's saying. Okay? If it is greater than 0, it's going to lie above the original graph. If it is greater than 1, it's going to lie above. Less than 1, it's going to lie below. Okay, so with all of those rules in place, let's go ahead and try to graph actually, I don't think we want an extra page. I think we just want to graph it right on the top. So if it is less than 0, all of this stuff does not exist, right? If it equals 0, it's going to be invariant. And if it equals 1, it's going to be invariant. Okay? If it's less than 1, if it's a fraction, okay, then the square root is under the graph. So it'll look something like this. Otherwise, it's over. Square root of 2. Oh, whoops. Yeah, I think this gives the best. Yeah, I think this shows it the best here. So you can see the two invariant points, and you can also see that the square root of 4 equals 2, and so that's why we have those different values. So I think I have this written backwards. If f of x is greater than 1, it lies below the graph. Yeah, this has to be below. And this is above. So the reason for that is when you square root like 4, it goes to 2. But if you square root like 1/2, it actually gets you, or square root a quarter, there you go, that works better, it equals 1/2, which is actually getting bigger. Right? So in this case it gets smaller, so that's why it's below the original. Okay, and so this one is, since it is a straight line on that y equals 4 line, it makes a straight line in the square root function as well, because it's basically just a square root of every point. So actually we could probably draw this a little bit better, because this has 4. So it should look more like this, like that. There you go. Okay, solving radical equations graphically. So, we have this equation. The x-intercept is equal to k. The value of k to the nearest hundredth is. So we don't know the x-intercept. So what we're going to do is plug this into our calculator and see if we can figure it out. So we have square root of -2 x minus 4 minus 5. So we're graphing that function. It looks kind of funky, but we're looking for the x-intercept, right? So if we look over here on the left-hand side, it does look like we might have it. Let's just make it a little bit bigger to be sure. Maybe go to 20, and it looks very clear now. So we can find the 0, the left boundary, the right boundary, and right about there. And so we have that x equals, and that's negative 8.5. And so actually what I should do, this question should say negative k. So what is the value of k? That way it goes to a positive value. There you go. All right, so very quick overview. Maybe we can do just one more example. I'm just going to do one more example that can hopefully make this a little bit, wrap it up a little bit nicer. So let's do another example, but let's do 3, or let's get rid of that one actually. No, let's do 3, and let's move it down by 6, and let's flip it horizontally. So let's put a negative. There you go. Yeah, let's try that. Okay, so we're going to try to graph this. There's a couple things going on. So first of all, again, a reminder, I like to get a good idea of what the original equation is before I start making stuff up. So this is the original equation. Looks something like that. Okay, this has a bunch of things happening to it. So first, it has the reflection and the stretch in the y direction. So reflection in the x direction, stretch in the y direction. So let's just go ahead and first do the reflection. Okay, so that is the reflection here. And now let's do the stretch. So every point just gets tripled. So that point goes to there, that point goes to, so it's 2, so it goes to 6. This point is 3, so it goes to 9. Looks a lot different at this point. And now let's do our two translations. So our translations move our origin point down by 6 and to the right by 5. Okay, and now I just look at kind of the change in value. So 1 to the left, 3 up. So 1 to the left, 3 up to get my next point. And then I look at the next change, which is 3 to the right, 3 up, which would be there. Then I look at the next one, which is 1, 2, 3, 4, 5 to the right and 3 up. 5 to the right, 3 up. So it's here. So, ooh, that's not what I wanted. There you go. So now we can kind of see how that would kind of look there. And actually, if we went another 7, 1, 2, 3. Oh, no, it won't be. Uh, 1, 2, 3, 4, 5, 6, 7. It'll end up being over here somewhere, so we'll just keep the curve going. There you go. It'll look something like that. Oh no, that was painful. Okay, so you can see how I stretched it one at a time, and I think this one was a little bit better. So step 1, step 2, and then step 3. Okay, so do your translations last. Okay, do the other parts first. Okay, this is based off of, again, the mapping notation, if you want to think about that as well, which is this here, right? So because of bed mass, you do your A and your B first, right? So that's what that's based off of. All right, so I hope this video helps you better understand radicals and radical functions and how to take functions and make them into radicals. Good luck.